escape
yeah.
towers,
The fourth
solid
platform,
module?
as I mentioned, the fourth rotational platform has opened first. You can see that the emergency escape system has already, we can see that. So as Mr. Yang Zhao has asked, the
各号注意，我是东风，第一次综合检查，5分钟准备，景山。营山明白。华山。
华山明白。
Yeah.
And it'll be the first
time. 明白。太原。明白。渭南。明白。青岛。明白。天津。明白。酒泉。明白。青山。明白。双城。明白。5号。明白。
Yeah, you can see this the solid rocket.
Yeah.
Professor Zhang, so China has several generations of the Long March rocket, right? So why is it that after all these new generations, they've come back to the Long March 2?
It's the really reliable one. This one, as Professor Yang mentioned, the reliability coefficient isn't that high, it's 0.98 something, but it hasn't failed. It's 100% success rate. The space shuttle has a theoretical higher reliability rate, but it already failed sometimes. So it's theoretical. But the safety feature is enormous. So apart from this one, this is used for really low altitude. When it goes really high up, when this thing gets jettisoned, there's another escape, high altitude escape on the fairing itself.
Yeah.
And
yes,
then
quite right.
After that, obviously, when the fairing drops off, you can just come down like the usual how you return. So its safety coefficient is extremely high, 0.999 something. So yeah.
So can we expect this rocket to be used for the future launches as well, for the 15 and potentially after
15
that?
and a few after that.
The Shenzhou 15 and its rocket, the Long March 2F Y-15 rocket, is already standing 1.5 kilometers away from the launch pad in the vehicle assembly building. It's already there.
Yeah, they're standing by. That's why we...
And we can see that the emergency escape has already been exposed. So the first part of the emergency escape is this emergency tower. This tower has several solid rocket engines for in emergency case to help the spaceship to leave the launch vehicle to a certain distance. And another part, as Professor Zhang has mentioned, is some rocket engines, solid rocket engines on the payload fairing. So after about 120 minutes, the emergency escape tower will be jettisoned. And after this, if anything wrong happened, the payload fairing, the rocket engines will help the ship to leave the rocket. But after jettisoning of the payload fairing, if anything wrong happened, because this is already the second stage of the rocket. So at this moment, the Shenzhou spaceship can use its own engines to leave the launch vehicle. But I should emphasize that in all these procedures, if this...
Can you see this picture? The Commander Chen Dong is using a...
What is he doing?
That was a specially designed, I believe it's the pole to touching on the screen.
Oh, like a touch pad thing.
That's right.
You can still see his handbook. Because you know that the launch itself is a very, very complex procedure. There are all kinds of checkings, all kinds of status confirm. So they must have this handbook to check one by one.
Surely this is something they've already read millions of times in the lead up to this.
And it's a very similar process that when they were the pilots.
So as Mr. Yang Li has mentioned, one tough thing for an astronaut is that they must repeat something one time for so many years.
Just learn everything by word.
It's a little bit boring, but they must face that.
That's part of their training.
It's protocol.
And very boring.
But in fact, though, the escape system is automatic. So this is why you can't really have normal scientists, normal ordinary people just going up there by themselves.
That's right.
Hopefully in the future, you can have voice assistants say.
That's right. And we're training the civilian.
Yes,
the payload. The payload specialty, I believe.
So we're looking now at just some prompt there saying that we're in the 2 hours countdown, and also that they're doing their first comprehensive check right now. That everything is in order and ready for launch.
What Mr. Yang Zhao mentioned is belongs to the third group. You know that for the first group and the second group of astronauts of China, all of them are chosen from the pilots from the Air Force.
Yes.
But for the third group, we have those from the engineering field and those from the scientists. So these will be the mission specialists and maybe payload experts. Those belongs to the third group, and they will perform more complicated experiments in outer space.
Professor, sorry, did you say that the emergency escape is automatic? Is it? Is automatic. So as long as if any of the parameters are breached, this would automatically launch, and they would.
They will be yanked out straight up away from the presumably exploding rocket, and then at some stage the spiky power thing will detach, and then the capsule containing the crew would drop down with a parachute and then land. They have actually optimized that procedure as well. So nowadays the rocket can fire in specific directions, so the parachute doesn't get blown back into the explosion site.
They're counting down.
That's a simulation.
That's still a simulation.
Another simulation.
Yeah, this will be the last. Maybe this will be the last simulation before the real launch.
But then do the astronauts also have control over this? Can they manually execute an escape and abort?
The escape, yeah, but once thereafter, they will be blacked out. They can't really do much.
Remember the rocket, the socket on the top of the fairing, they will be ignited if any emergency happen, and it will take those cabin away from the rocket.
Yeah, what you mentioned will be the first separation, the jettisoning of the emergency escape tower. The first critical
Yeah, the
step
first
of the launch.
200 seconds or
About 120
120
seconds.
seconds,
120
120
seconds after the launch.
La Agencia Espacial China.
And also, Professor John, and I believe scientific research has been very, very critical parts of the Shenzhou 14 cruise. Do they have to? Have they been trained to how to conduct those scientific experiments, or those experiments can automatically be conducted by themselves?
They have to do some operations, and obviously they can contact people on the ground, but the design of the experiment has to be pretty self-contained. Involved in proposing some other experiments, so you have to essentially make it a black box, and you can't expect people to repair it. They don't have the tools anyways.
Yeah.
So that's
the last time I remember I talked to Tricia LaRose, the researcher from Oslo University, who has one cancer research. The cancer research will be carried out on the Shenzhou space station, and it said everything is automatic. They don't need this astronauts to do anything about it. So everything has been set up.
They just have to take it there.
Yeah, just to take it.
So that's why it would be so good if the third generation have some experts in this. They can actually change the procedures depending on the outcome of the. Because it costs a lot to go out.
That's right.
You want to extract as much.
It still needs these people to maintain, to maybe repair something.
Anything
happened.
Now Mr. Chen Dong will wear his gloves.
But what do we know so far about the third batch of astronauts that are in training right now? What kind of backgrounds do they have then as well? It wouldn't, not just pilot.
16 of them, young, they're in their 30s. Specific information hasn't been released, but they had mission slots.
According to Ms. Huang Weifen, also we have female astronauts among the third group. We also have. And you know that part of them were chosen still from the Air Force, because you know that for any crewed mission we need the pilots, and also for the Shenzhou spaceship at least the 2 of the 3 astronauts must have are qualified pilots of the Shenzhou spaceship. In emergency cases, they must have the capability to make the right choices. So you can see that during the G-force training, in emergency case, although you know that in a normal flight, they will experience 3 to 4 G of G load. But in an emergency escape, it can up to 8 G. And during this process, they must have the capability to press the right buttons.
So in the future, we're looking at So in the future, we're looking at a group of astronauts going up there, potentially being a mix of pilots and specialists, as Dr. Zhang's saying.
Exactly.
So that gives them a lot more flexibility and options up there.
Eventually, tourists, hopefully. They did mention that in the future, Tiangong has a plan for more sort of touristy stuff in its far future.
Oh, you can see Miss Liu Yang has already closed her helmet. All of them.
All right, well, we're looking at this is the preparation for the launch of the Shenzhou 14 crew up to China's space station. This is our special program. We'll be following all the preparations and to the launch and after that as well when they're on their way to the space station. Do stay tuned. We'll be right back with more.
The quest for space heats up as China races to finish its space station by the end of the year.
5 more.
Just to recap, they will be up there for 6 months on the Tiangong space station.
And Wang Yaping are also at the second.
Yes, all of them belongs to the second group.
Second group of the Chinese astronauts.
So as I mentioned, we have 5 men and 2 women in the second group.
And it'll be some time before the third group of astronauts will be done with their training, wouldn't it?
The third group has already been selected, and also we have female astronauts.
神舟14号载人飞行任务准备完毕。
And they're saying that the preparation is ready.
中国人民解放军航天员大队航天员陈东。
The commander introducing himself.
刘洋。航天员蔡旭哲。
They've been asking for permission to.
是。敬礼。
So some other crew members. All 3 astronauts will be heading to the launching site.
And that launch will take place in about an hour.
This is not very far. It's not very far from the Wentango, right? It's like 20 minutes drive.
Also, you know that's they take a ground vehicle to the launch pad, and also they will use the lift to the 9th floor of the service tower.
So these 3 astronauts have been in quarantine in the lead up to this, haven't they, Professor Zhang?
Yeah, you don't really want to bring any sort of virus or bacteria out there. You get sick, then you might have to abort the whole mission to come back quickly. That's not something to look forward to.
How long would this quarantine have been?
About a week, if I'm not mistaken.
So when would be the last chance for them to see their family in person? I mean, I suppose here, would they be able to say goodbye in this send-off now?
I'm not sure I see their families there.
Usually their family member will among the audience.
But they wouldn't be able to have any...
I can still remember last time the daughter of Miss Wang Yaping also is among the people and called her mother.
Nowadays, it shouldn't be that much of a problem because they can just call them from space anyway.
Right.
It's a lot easier.
Yeah, they can communicate, right? They can,
Yeah.
They can still communicate and send messages to their families.
So this procedure we have seen is our Chinese tradition. It's quite different from that of Russia. You may have heard of that. You know that during every launch, every Soyuz launch, the male astronaut will pee on their way to the launch pad because this tradition comes from Yuri Gagarin. During his first flight of human being, so he peed during to the wheels of the ground vehicle. And for
now
female,
become a tradition.
So for the female astronauts, because it's not very convenient to do this, so they will before this course, they will put their urine in a bottle and pour that on the wheels.
this is Russia now, right?
Right, but not something that we're
That's-
seeing here.
that's a Russian-
So that's represent best wish for the safety of the journey.
Un saludos para todos.
They should have their own tradition.
Yeah.
I guess they do, right? They eat baozi.
They do?
They
Before
eat
they leave, is
baozi,
that
right?
the last
They
thing?
eat baozi before lunch.
The last meal on earth?
Boss is not only.
And they will also sign. They will make the signature on the door of the dormitory.
Usually, you know that for me, before the launch, I always eat 3 balls for the success.
So you're following the tradition as well.
Yeah.
Does that correlate with the number of astronauts? If there are 6, you're going to have to really stuff yourself.
So we're looking at the weather right now. The conditions look pretty good over there, right? So this is sort of an ideal condition for launch, Professor Zhang?
Yeah, it looks like so. If the wind is too much, it can knock the rocket off course a little bit, but of course you can gimbal the engine to bring it back. But lightning will be a problem. It will fry the electronics, even navigation, to make it lose control.
But when we talk about wind, I mean, how strong wind would it need to be to have to cause an abort of the mission? Gale force? I mean, surely not just a...
That really depends on the safety margin. Well, today,
You're
looking
hearing
at the
the
screen,
crowd is cheering and waving goodbye to those astronauts. And now they're heading to the launching pad. And Jiuquan satellite's launching system.
And the medics will stay in the same vehicle with them to take care of our astronauts, and also to ensure that, because you know that they are already wearing the IVA spacesuits, so must keep that in a very good status. And also, sometimes, you know, you may notice that they will have a small box in their hands.
A small what, sorry?
A very small box.
Okay.
Small box. There are also pipes connected to their spacesuits. This is to provide some ventilations, because in some cases it will be very hot inside the IVA spacesuit, and with this ventilation device, they will cooling down.
And the 3 taikonauts led by is Commander Chen Dong, a veteran of 2016 Shenzhou 11 mission, are on their way to the launching site. And our reporter Ning Ho joins us on the scene. Hello, Ning Ho. How are the preparation going now?
Yeah, we're now in a platform that's about 1.5 kilometer away from the launch pad. And you can see over here is China's only manned space launch pad. The rocket is in position, and you can see it's a clear blue sky with barely no wind. So we got a
12 mission and 13 mission. But according to the description from the astronauts, we do have improvements of these missions. You know that we have the treadmill, have the space bicycle inside our Tianhe 1 core module. But the schedule every day has also been improved to strengthening their exercise of their muscles. And
Improved as in giving more time for exercise.
Yeah. This also is a very important measure to ensure their safety. You know that not only during the liftoff, but also you know that during the re-entry, there are also very intensive vibration and G-loads. When touching down the ground, you know that although we have all kinds of measures to reduce the impact, but still it is a challenge for our astronauts. To ensure their safety, they must be in a very good physical condition to ensure their safety. So the exercise is one of the important things they must do in space. But how can we arrange the schedule? And for each part of the exercise, we must do their most. So we do not have this kind of experience before. So we can only test the relative technologies during the Shenzhou 12 and the Shenzhou 13 mission. So I believe that even for this mission in the future, we will have improvements.
So prior to them reaching the Tiangong,
及分离点参数发出，景山。影山收到。东风。东风收到。
so this
They are
is
announcing
again
the
checking.
parameters of those separations, the critical separations, as we have already discussed.
So prior to them reaching the Tiangong, they would have the vitals monitored by all these the sensors attached to them. But when they get to the Tiangong, they'll be doing this themselves, I presume, with all kinds of machines there.
Yeah, But before that, what we do, the most important thing is to switch the status of the Tiangong from an unmanned status to a manned status. Especially, that every time when I can still remember that after the Shenzhou 12 and the Shenzhou 13 crew entering the Tiangong, they must switch on the oxygen producing equipment.
That's right.
Because we don't bring oxygen tanks to the station, but we use the water. We use electricity to produce oxygen from the water.
Everything is recycled on the space station,
Yes,
including
and
the
also
water, the oxygen inhaled.
to switch the status from the unmanned status to a manned status, producing oxygen will be the most critical and important step.
And you're watching the live picture of the launching pad in Jiuquan satellite launching site. This is the launching center, right? This is not launching site.
You can see that at this moment, still the from bottom to up, the first, second, and the third platform has still closed, and within these arms, within these platforms, there are also several rotational arms with cables and pipes connected to the launch vehicle.
And they'll be open from the top to the bottom.
No, the first one, as mentioned, the first one is the top one opened, and then the sequence will be the opposite. We will open that from the bottom.
And it sounds like from all the checks that everything is going smoothly and as planned.
Great.
So that the first comprehensive check has come back as normal and expected.
Yeah.
Since that three astronaut is
We should notice that at this moment,
still reading their protocols.
At this moment, if anything wrong happened to the launch vehicle or the Shenzhou spaceship, because the fourth platform has already opened and the emergency escape system has already exposed to the outside. So at this moment, the astronauts can use the emergency escape to leave the launch pad in a very rapid speed.
You mean they will ignite the motor on the top?
Yeah. So at this moment, they can do that.
There's something I'm curious about. So these are three-man crew, right? So obviously they have to have some sort of synergy and good understanding with each other. They probably train with each other as a three-man crew. And I know that there was a backup, a three-man crew backup as well. Yeah, waiting in quarantine. So if say one of these astronauts had to drop out for whatever reason, would they just switch the entire crew, or would they just have one person stand in?
Usually, we will change the whole crew.
Okay.
So these guys, the Shenzhou 14 crew, they were the backup for the Shenzhou 13, right?
Oh.
Yeah. When a Shenzhou 13 is departing out, and all three of them are standing by.
So which means they've been through this process several times now.
That's right.
They shadowed all the tasks of the last crew, so they really know what's going on.
So
would this is, I guess, comparatively easier for this crew, would you say, compared to last? Because for a start, they're not the first ones to do the 6 months stay already. There's already predecessors before them, and they've had people, I guess, trying things out already.
Yeah, I guess their predecessors had already told them everything to expect, so that in that respect it would be easier. But they haven't been there actually for 6 months, so.
And they've got very critical stages to complete up there, right, for the Tiangong. So that must be enormous pressure as well.
Right.
But that the daily life in orbit is very busy. And that the Tianhe-1 core module is a very, very complex spacecraft. So there are many status, and also that you cannot sure that everything is always in normal condition. So for anything abnormal, you must have the measure and the preparation for these kind of things happens. So the experience of the Shenzhou 13 crew is very, very important for the Shenzhou 14 crew, and they must tell the Shenzhou 14 about everything.
Right, exactly what to expect.
They must pay attention.
Even the psychological aspect as well. I'm sure there's a lot of advice on that.
So they are already been very good brothers and sisters. And they, as Ms. Liu Yan has mentioned, they have stayed together for 2.5 years. So they are very.
They spend more time than they spend on with their families.
They can even understand each other with a very single gesture. So this harmony are also a very good, very important figure of their final score. they will be chosen as the normal, as a formal group or the backup.
Oh, I see. See how well they get along. I mean, that's important. There's
Yeah,
three of them stuck for
important.
6 months together in a
Better
small
be able to work
space.
together, or else no, we'll go.
Can't think of many people I'd want to do that with. I don't know about you.
So how long has the three astronauts been teamed up? Like for 1 year? Or they have to
More than that.
More than 1 year?
More than that. Yeah.
The crew was chosen more than 2 years ago, I think. And then they are all from the second generation, so everything's still chosen, which was 2011 or something.
So the Shenzhou 14 crew
been
has been,
working
the
together
site
since
has been determined 2 years ago. With
Or
the three
just the combinations, perhaps,
combination.
right?
Yeah, but they know each other for like forever, yeah.
Outstanding in a certain test, but also the score of the whole team will be the final figure to choose them as the primary one or the secondary one. So this is also, there is no exception, not only for China, but also this consideration is adopted in other countries. So we do have these examples before in other countries. For instance, what I mentioned is the Soyuz 11 disaster. Three cosmonauts lost their lives. Originally, the formal team is another three cosmonauts. Because one of them had some illness, so the whole team were replaced by the backup team. So that's one example.
But they have very clearly demarcated lines as to who's doing what task up in there, or is this something they all have to be trained in because you never know who has to stand in for someone else?
Well, you know that for the lift off.
People there seeing off our hero astronauts, and the big board behind the astronauts showing you all the previous missions China has completed so far. 12 astronauts, 17 trips, 7-man missions so far. And you know, last time when I covered the Shenzhou 12 mission 4 months ago, there were only 11 missions with 11 astronauts, with 6-man mission.
Yeah, it will be the first flight for one of the astronauts this time.
Chief Commander,
我们奉命
we
执
are
行
the crew
神舟
to
14
carry
号
out the Shenzhou 13 manned space mission.
准备完
airlock, but that's a temporary one. As Professor Zhang has mentioned, the main airlock will be located in our Wentian module. And this airlock, the inner volume is much larger than the node. Moreover, you see that the hatch on this main airlock is bigger than the node. You see that the diameter of the hatch on the main airlock is about 1 meter, and the size of the hatch on the node is only about 0.85 meters.
So this airlock is where they'll be doing all the EV.
Yeah.
So
the
after
access
Wentian
for
come
it
into
into-
orbit, the node will be used only as a backup. So usually in most
But
of
the
the
last time they used the
node.
core module
Yeah,
as
yeah,
the
yeah.
access
Yeah.
to carry out their EVA, the spacewalk.
Yeah.
But this time they're going to use the airlock in Wentian.
Yeah.
That's going up in July, I believe.
Yes. So the node is the connecting hub between all the different things. So once that's used as an airlock, you can't access. So the guy is stuck in the core module. He can't go to the crew module to escape. So that's the main problem. So this time, once that goes up, then not only you can escape, you can actually come back from a different airlock.
Right after 1.5 hours, we're going to see this the launch off of the Shenzhou 14 mission. And for the latest on the ground, let's go live to our reporter Neil at the Jiuquan Launching Center. Hello, Neil. What do you have for us for this hour?
Hello. Yeah, well, this place where I'm standing on is the platform that you could see the launch pad. It's just about 1,500 meters away from us. So this is the closest place where you could feel the tremor when the rocket lift off, and also feel the blast of the engines. And you can see that well, the rocket was moved into position several days ago, and then it will go through all kinds of checks and tests as well. Because ever since Shenzhou 12, whenever there's a manned spaceship ready to launch, there's another backup rocket and also ship standing right in the building beside me, waiting for as an emergency ship for emergency launch. So this rocket actually has stayed in position like this in the rocket place like this for over 10 months. So this is the first time that rocket has been standing like this for so long. So the engineers are testing all systems to ensure that the rocket is in good condition. They pay extra attention to this rocket to ensure that it's 100% safe. And now you can see that the rotating platform, supporting platform on the top has opened, where you see the tipping point of the rocket. That's the escape tower, which you could only see on manned space rocket designed for manned spaceships. And what you're hearing now is broadcasting to the entire field to letting people know the conditions of the rocket. And in just about an hour ago, the taikonauts have entered the spaceship. Also, people have been closing hatches of rockets, of all the hatches in the rocket. And now we are within 90 minutes countdown. So the people will keep checking all the conditions, including communications in the rocket. And actually, there are still people working on the launch pad. The last group of people will evacuate from the launch pad 15 minutes before the launch. So people will be monitoring the condition until the last minute of the rocket. And about the crew of the Shenzhou 14, they have carrying really heavy burden in this, and will all be docking with the space station in their watch. And they will also greeting the next crew, the Shenzhou 15 crew, in orbit. And also, they will be the first taikonauts from China to spend national holiday as also Mid-Autumn Day in China Space Station. And while everything they need have already been there waiting for them, the cargo ship Shenzhou 4 already docking with the space station. And the first thing they go up there will be open up all these equipments, all those things that prepared for them. I'm sure there will be many surprises as well. Yeah, that's what we learned so far. But
Thank you. That's our reporter, Nihon, bringing us the latest situation as the 90 minutes countdown. Appreciate it.
Well, so as we were saying earlier, they have of the astronauts training system for China's manned space program, and asked about the Shenzhou 14 mission and its crew members.
The crew members of Shenzhou 14 mission are all very diligent and careful, and they have great teamwork spirit and friendship. All three of them are devoted to research, but have unique personalities. Chen Dong, as commander of the team, is always confident and decisive, and focuses on details. He often contributes suggestions during training and experiments. Liu Yang is very friendly and modest. She has very good communication skills. And Cai Xuzhe is really, really smart. He is good at learning new things and comprehending new information. Overall, they are good learners and thinkers.
Will there be any spacewalks, and how will they contribute to the construction of China's space station?
Shenzhou 14 is the first manned mission during the construction phase of China's space station and has great significance. During the 6 months mission, the taikonauts will test 9 different formations for the assembly of the space station, change the capsule position twice, and conduct 5 dockings and 3 separation and evacuations. They will also coordinate with the ground to complete the construction of the station. The crew will do 2 to 3 spacewalks using a combination of airlock module and big and small robot arms. They will for the first time enter the Wentian and the Mengtian space labs to unlock and test more than a dozen of experimental boxes. In general, they will undertake extremely difficult tasks. I should say, this is the most difficult part of the construction phase.
Professor Zhang, we just heard the chief designer talk there about the small robotic arm that's going up there with the Shenzhou 14. A robotic arm attached to the Tiangong. So you could just compare the two for us.
So the one's already up there is a really long one. So having that lens, that ridge, is good, but it swings quite a bit, obviously. So the precision isn't as that high. The small one is more precision based. So the aim of having that is so you can put stuff on the outside. So there's some experiments where you need to be exposed to the outer space, for example, testing materials how today and detecting cosmic rays, that sort of things. You don't want people to go out there that often. The spacesuits have a limit of number of use, so you want to use that small robotic arm for it.
Even though it was just pretty cool.
Yeah, but in the future, more sort of automation is because it's going to be a production line. There are like 25 racks inside, and then I don't know 50 spots on the outside between the two lab modules where you can stick stuff onto. So that's going to be intense if you want to do it human way. So the robotic arms will be very important, and quite interesting. The small arm can be attached onto the long arms.
And what would be the difference for bigger robotic arms and smaller robotic arms?
So the big.
Open up now.
So the next step, we will open the platform at the bottom.
I think that's already opened according to.
And we see this breathtaking view of the Gobi Desert landscape.
What we have just discussed is called the small arm. It will brought to the station by the Wentian module. It is 5 meters long, and also the mass is
so
half.
So the big arm is already there.
Is already there, brought to the station by the Tianheban module, and
the
feature
robotic is coming up with the Wentian.
Exactly.
Okay, not with
So the big arm can moving objects more than 20 tons. So it's very strong. For the small arm, you know that's the length is 5 meters, and also the mass is half of the first one, but it's more precise. You know that's the accuracy and positioning is 5 times more accurate than the big arm, and also the accuracy on direction or the attitude is 2 times more accurate than the first one. So for some precise operations, we will use the smaller one. And also, you may notice that during the Shenzhou 13 missions, during the second spacewalk performed by Mr. Zhai Zhigang.
我是东风，景山请讲。景山，预置指令已发出。东风明白。
And also routine communication with their
what we heard the voice means that the Jingshan, what we call the Jingshan, is ground station. And the its ground facilities, for instance, maybe some radars or the optical telescopes will direct targeting to a certain position according to the trajectory.
That's just the protective case for the space shuttle.
So after separation, about 210 after the liftoff, we will separate the payload barriers. It's already high enough, and the air density is already low enough.
So this small, so back to the small robotic arm. So it's great that they can repair themselves, repair each other. But with the big one, in the previous EVAs, that we saw how the astronauts were able to attach themselves onto that arm and move around. Is that something that can be done with the small one, or is that one now?
Yes. You know that, of course, as I mentioned, the big arm can move any objects more than 20 tons. But obviously, the astronauts is much smaller than that.
Well, but the EVAs
So the advantage of using a robotic arm is to moving the astronaut very in a rapid way. And also, in this case, the astronaut can bring very big objects together with him. For instance, if we want to install something very big on the surface of the station, we can use the robotic arm to move both the astronaut and the object to the certain location. Of course, we can see by one astronaut, but in this case, we can only move some smaller objects, not very big ones. So with the help of the robotic arm, we can move very huge ones.
And John Paul just mentioned about small arms will be used more for the scientific research parts.
Right.
And especially, I heard there will be an exposure experiment. The scientists want to in the outer space.
Yeah.
And you might use the small arms to grab the things, and you want to put it in the outer space and let them expose to the radiation from the outer space. Tell us more about this exposure experiment.